Hi guys, in our last video, mail time, we had showed these two Yaesu FL101s, and the guy that dropped them off and gave them to me said, you know, they both were working. When we connected this one up, it does work, it transmits. It has a few problems. This one would not transmit at all. And the funny thing is, you know, whether it's your radio or one that someone is bringing to you to look at, and you're going to try to troubleshoot and work on it, always listen to what they tell you, because a lot of times with what they say will just about give away what the problem is. We connected this radio up, and sure enough, there was no output at all. Plus the meter was pegged over to the far right. Now I tapped on the glass and the meter came down, so the meter is stuck. So one of the first things that we need to do is just check out this meter and find out why it's sticking. And we'll probably have to pull the bezel off and loosen the meter up and get it out. I can't quite remember. I think there's maybe only 2 bolts behind it. But we need to get that meter out and get it freed up. Because on these radios, if you're tuning it by the manual, you'll need the meter to set the bias control and for final tuning. Now you can do the final tuning on a watt meter, but I prefer to just do it by the book and use the meter. And we'll use the spectrum analyzer too when we go checking the transmitter to find out just what's going on inside of it. Haven't really had time to look at it yet. I only had them for a few days, but I figured it'd be a very simple troubleshooting exercise that we could go through, because, you know, basically this is just half of a Yaesu 101 transceiver, like the B, E, or, you know, F or whatever. It just doesn't have the receive circuit in it. It's got a little bit of a different display. So we'll go ahead and take this one apart. We'll pull the meter out and see can't we get the meter fixed. And once we get the meter fixed, we'll look at why there is no transmit. I removed the top cover, and you can see the meter is sitting just down in there. And there is a couple of screws that's holding that meter in. You got a couple that's right here, one here, that's one down there, and then there's 2 that's run straight in. Let me move the camera over, straight in this way. So the best way to access this meter is go ahead and pull this outer shell here off the radio. And there's only 3 screws on the top, and 1 on each side and a few under the bottom. And once those screws are removed, we can go ahead and move the shell off the radio. This will give us better access to getting to this meter. I've got the shell off, and you know, you can see it's that dark gray, and we rather have it this gray of the original Yaesu 101s. So I'm going to have to get some of this paint mixed up so we can paint the shell, the top, and the bottom cover inside and out so it'll look factory. So I might have to have a painting class on how to restore cabinets back to their original look and finish here in the future. But as you can see, with the case off, everything's a whole lot more accessible than what it was before. So we should be able to get down there and remove any screws. Now, you probably can get to it without doing it, but to make it easier, you have these 2 boards here. If you just go right down in between the 2 of them, there's a metal plate separating them. And you can just simply remove those 2 screws like so, and then take these two units and pull them right out as one unit. Now this gives you plenty of room to access that meter. So all we'll have to do is get in here and remove these 4 screws that's holding it in place. They will have a green Loctite on them, so they're a little bit tough to get started, so you need to make sure you're using the right screwdriver to fit the screws. And I can see that the bottom screw is missing, so it looks like maybe somebody has already been in here and has tried to do something with it, but we're going to try it ourselves and see what we can do. Now before we remove the last screw that's holding it in, we'll go ahead and take a nut driver and back these 2 nuts off the back for the wiring. If you ain't sure how they are supposed to go back, you know, just the time where you take a picture. But you know, a picture can save you a lot of trouble when you go to put stuff back and trying to remember where the wires went. It helps quite a bit. Okay, I have the nuts loose and off. Keep your eye open for any washers that's on there, like this one. Now we can simply take this harness and just push it back out of the way, and we should be able to get our screwdriver right down here to this last screw. I use a magnetic screwdriver that helps to keep from dropping the screws. Now the washer that's locked tight to the frame, but now we have our meter out. So a lot of times these meters will just stick due to age, you know, metal moving and going from temperature to temperature. So we're going to get in here and see if we can't take our little piece of glass off the lens of the meter. You have to be real careful so you don't break nothing. And it's a little bit too tight because of this metal bracket. So what I'm going to have to do is loosen up these 2 screw nuts here, just holding the meter onto this plate, so it'll loosen up the room for the meter. Now the plate's off. The bottom lip on it was kind of tight up on the meter and was holding it in there, so I couldn't pry it loose. So if you look at the pointer right in the center, you'll see this little tiny screw right here. And normally what happens is, over time, you know, like I said, the metal moves and this pointer just gets real tight and doesn't want to move like it's supposed to. So what we want to do is just ever so slightly loosen this little tiny screw. So to do that, you got to make sure you use the proper screwdriver that fits everything. And we can get right in there and to that screw and just back it counterclockwise, and you saw the meter go down. Now it is loosened up. Now if you take a little drop of Loctite, serviceable Loctite, like the blue or the green, and just put a little drop on there. You won't have to worry about it moving no time in the future. Alright, so I use some clear, and while you're already in there, just go ahead and set your meter to 0, and then you want to look at the space between the meter and the face of it, and you can see that one is all but touching. So I'm going to put this back down here. I'm going to take my screwdriver, get right up here next to the bottom of it, and give it just a little bend upwards. And that's all it takes. And now our meter should be good and free. Now another way you can bend the pointers by using a pair of precision tweezers, and just get right down here on this vertical piece and just give it a little bend, and that'll bring it to where it needs to be also. Alright, when you go put the lens back on, make sure that your dial pin is lining up with the bottom positioning adjustment, so that you don't bend anything out of place. And we should be good to go. We can now adjust our meter where we need it and let it go. And don't forget, when you got your meter out, go ahead and clean your lens. You're probably going to build up some static on it, and you'll see the meter just go and stay from the static. And no problem once you get it bolted back into the radio. Most of the time that static will dissipate long enough so that it won't cause any problems. And our meter is back in place. I've got 2 circuit boards mounted back in. Wasn't hard at all. Very simple job to do. And you can see why I said it was very important to set that meter to 0 before you put it in, because in this radio you cannot get to the screw without removing the front bezel or taking the meter back out. So make sure when you got this meter out, you set it back to 0. And speaking of meters, let me get this light there moved. At the end of this video, I'll be looking at comments, and I'll be giving away this Heathkit IM18 vacuum tube voltmeter. And I'll check the tubes and make sure the tubes is fine, and I'll also send the replacement capacitors for it, and you can rebuild this meter in your own spare time. There should be nothing really dramatic that's going to cause any problems with it. I will check it out and make sure everything is working. In fact, I think I've already checked this one out and made sure everything is working. There's a little scar up here on the needle face. It's kind of hard to see. You can see it right there between the 8 and the 10. But other than that, the rest of the meter looks good. That will probably buff out. So a little bend will in top of the chassis here on the front plate. I'll straighten that back out. But some lucky viewer will get this nice vacuum tube voltmeter. I'll also make sure it has both screws in it. I see one of them is missing. Just has a 3-wire line cord on it. The cord looks good. It is polarized with a it's even got cobwebs on it. I might take those off, not let you have my cobwebs. And it has a ground lug on it. So yeah, I think it'll be a good meter for someone. So stay tuned. One of you guys will receive this nice Heathkit IM18 vacuum tube voltmeter. Okay, I can already hear some of them guys out there hollering at me, oh, what a rookie mistake. Look what he did. He fixed the meter movement without even checking the meter. Well, I did that for a reason. I wanted you to see how to fix the meter movement. But the main thing we need to check also, is the meter any good? And when you go to check this, just don't grab a voltmeter, especially an analog voltmeter that has a 1.5 volt battery in it, and put across these terminals, because just the current in ohms mode can exceed the current handling capabilities of this coil in the meter and burn that coil out. Then you'll have a meter that is no good. So just like I say, just don't grab no voltmeter and stick across here. There's certain ways that we need to do to check these meters to make sure that they are working. And one of the things is a visual check. Alright, so here is a shot of the meter coil after I took the unit apart. And you can probably already see it. Now you can see the coil spring that's wrapped in there. Looks pretty nice, no problems at all. But look at the coil winding right down in there, and you can see a couple of the wires. Looks like it's got little burnt balls on it. Look right there at the end of the screwdriver. You can see that one there, and then you can see a wire sticking up right there. So what it looks like to me is that there was a problem under the final amplifier sockets, and voltage happened to come back up through the wire that goes to the positive side of the meter. Now it goes up and it goes through the meter select switch and then comes to the back of the meter. It then goes through a 340 ohm resistor that's inside the meter, and then to the terminal on the meter. And this is the results of what happened when too much current comes in through the meter. So this meter is kaput. It is shot, no good, non-usable. So what do? Well, we can go out and try to find another meter. And I'm going to do that. I'm going to see if I can just go out and find a replacement meter. Maybe catch one on eBay or somewhere. But in the meantime, I'm probably going to completely disassemble this whole unit and try my hand at rewinding that tiny little coil. I'll have to find out what the total resistance and inductance is, and then I should be able to wind a new coil around that and then put all this back together. Now you got to remember, you got a lot to deal with here, and I will not do this on camera because it is very tedious work and under the microscope the whole time. So you know, not only have you got that little coil winding to deal with, you got the springs on both sides of the meter movement to have to deal with, and it is a bit of a job. I've had done this several times, but I believe it will be no problems to repair this. It's just that it's a lot of work. But maybe we'll get lucky and find one. That's probably about the best I can get you zoomed in right there in the microscope. And you can see that thing is just, looks like over half the coil wire on the left hand side of that holder is just burn up and gone, and what you see is a little char left. Well, the meter's back together for right now until I decide what I'm going to do. Like I say, I'm going to look around on eBay and different places and see if I can find one. And some of you might be saying, oh, it's just a meter, why worry about it? You know, you don't have to have a meter. Well, that's true. But if you notice this mark right here that says idle, that is to measure your idle current. Because if you got too much idle current, you can end up frying your tubes. And these tubes are not getting as easy to find as they used to be. Now this rig does have a set of GE tubes in it. It doesn't have the original Toshibas. So you know, you want to keep an eye on this idle current and make sure the idle current is fine. Now you can put you in a jack in the back. They use a voltmeter to probably take something like the other FL101 I got and measure the current once it's set, and then do the same on this one so I can get it somewhere set where it needs to be, and then use a voltmeter and a little bit of math to figure out what it should be by looking at a voltmeter. That's a little inconvenient. That would be alright for myself. If somebody else was to run the rig, then it might be a little different for them, you know. So we really need to see if we can get this meter back working or find a replacement. Well, since there's not a whole lot we can do with the meter at this time, you know, I've already looked on eBay. I didn't see one. So it may take a while to find a meter. And it also, if I decide to pour this tiny coil out and rebuild it, that's going to take a bit of time too, and that time I don't have at the moment. So what we're going to do is just put all this back together, stick it back in the radio and bolt it back in and connect it back up just like it was a working meter. And then after I do that, we'll have a radio we can go ahead and start working on while the radio has no output. I've already got my assumptions. I haven't looked. I wanted to just do this with y'all, but I think I already know what the problem is, and we'll talk about that in just a minute. You know, plus by putting this meter in, we don't lose any nuts and bolts that we would have to save until we find this. I mean, it could be 6 months down the road before I could even find the meter or get a chance to rebuild this one. So yeah, I think that's the best plan of action at the moment. So I'm gonna go ahead and get this back in, and then we'll look at a few things and talk about a few things and look at the schematic on some stuff. Okay, so I don't know how many times I have said this in the past, and it still stands. If you'll take the time and listen to the piece of equipment you're working on, it will tell you a story, and it'll just about tell you exactly what's wrong with it, what's happened, and you know why it's doing what it's doing. So we already know this radio has told us two things. One, there's no output power. Now, I did not demonstrate this in the beginning, you know, so you'll have to take my word on it, but I've already checked it. And no, there was no output power whatsoever. The second thing it's telling us, the meter didn't work. We took the meter apart. We found out that the coil inside the meter is crispy. So that means excessive current has come up to this meter and have gone through the meter movement and burnt the coil out. So where do you go from there? Well, that's when it gets interesting. But it also tells me exactly where the problem is. So here is a partial schematic of the FL101, and we'll take a look at it, and this way I can show you better how to trace this out to find out what's going on. Now we know that when we take the radio and we put the meter in the IC that we're reading idle current, and we go to PO, that's power out. So this is actually, connected to the meter, and then the wires from this go to the bottom side up to the base of the tubes, and it pretty much connects to the cathode, and in the cathode you'll have a series of resistors and some capacitors. So if we look right down here, we can see our meter M1, and up here we can see our switch, and when it's in the IC position, you can follow this right on over through this coil and up, and you'll see this line here ties to the cathode of the tubes. So here we have a series of capacitors, and right here we'll have R19. Let me get the focus. Okay, here we'll have R19. This is our shunt resistor, and this is how we measure current that's going into the tubes. Again, back down to the meter circuit, you'll see power out here on the switch, and it comes up, goes through our varipotentiometer that's on the back of the rig. That's to set the scale, and then we'll go right on up and we'll pick off of our pi network, and we'll have some diodes and a coil and a blocking cap here to keep the current off, so it will supply voltage to the meter, so it will reflect a power output. Now over in this side, when we're in the IC position, if something happens in this tube where you get an arc, a flashover, or a short in the tube, it can throw voltage right through this circuit, and you can see it's basically going to be a direct connection to the meter circuit. There's nothing here to block it. There's no blocking capacitors or anything in this circuit that's going to stop it from hitting the meter. The only thing you have is inside the meter is a 340 ohm resistor, so that would put voltage directly into this meter circuit and blow the coil out. Now, one of the most common problems I have seen in the 101 series, regardless if it's the FL, the ZD, the FT series, is this shunt resistor. If you notice, if you remember back in my 101 series, this shunt resistor is just a core with a cloth covered wire around it, and it's not a very big wire. So this would be the first hunt I would go to for no power out. If this is open, this tube is not able to draw any current, and that would stop output. If this resistor is burnt or charred or shorted out with something else, then there will be no power output. And still, I'm not sure how, being shorted or burnt in two would have got voltage to the meter, not unless something catastrophic happened inside one of these tubes and it arced and got voltage through that circuit and into the meter. So now what we're going to do is just turn the radio over, and we're going to have a look for a first time ourselves and see what we see. With the radio sitting on its side, the front is going to our left. This puts our PA section here at the top. And just taking a look here, I'm not seeing anything that's burnt or charred or anything that's directly out of the place from what a normal radio would be. I am seeing something that's looking a little bit strange, and the first thing I see is this wire here that's got some type of heat shrink here, some heat shrink there, and it's running down. So I don't know if this wire has burnt up at the time or someone has cut it out and put it back in, but that is a little strange and will need to be replaced. That may be a little bit of a dog to get down there and trace it out where it's going, but yeah, I don't like to leave stuff like that inside the radio. Looking here, we can see our shunt resistor, and I'm not really seeing anything that stands out. It does look like it's a little bit loosely wound. If you notice, you don't see no charring or burnt spots or any. Okay. Wait a minute. Well, that doesn't look right. And what I'm seeing here is that there's no wire on the end of the shunt resistor, and it was right up against this terminal here, which that probably would have picked up enough voltage to send through the circuit and burn our resistor out. That is very possible. But this resistor is actually supposed to be connected to this rail right here. And you can see it's not connected on this end, only on this end. And if this was to go together and go up against these two connections, then that would throw voltage right on into the circuit and go shorting things out. Very interesting. I'm going to go ahead and get this shunt resistor took loose and find out more about what's going on in this circuit. I've got our shunt resistor out, and you can see that this pin is completely gone. The wire is still attached to this end. When I go to this end, I see the coil comes up and it just lay it up against this end, and it's not even soldered to it. It looks like it's been broke off and someone's twisted around and never soldered it back. So we will have to put an end on this side and then solder this side back up, and then I'll take a resistance reading on it and make sure that it's still, you know, has continuity across it. Make sure there's nothing open in it. But you know, other than that, it looks okay. It's just that somebody has been in here playing around with this thing and did a bit of damage. Now I am finding something else that's interesting that we looked at a moment ago. This wire that we're seeing here, that's not even supposed to be in the transmitter. And that wire is coming up, as you can see, it goes through there by the band switch, and then let me find it. It goes down somewhere in here and is connected to something down there. Well, that is not even on the schematic and should not even be connected. So maybe that's the voltage source that took our meter out. Now why someone did this, I have no idea. It doesn't make sense. So I'm going to have to follow this down and find out what it's connected to and figure out just what they have done here and why they've done this. Okay, I really had to look at that black wire again that they have soldered in there, and now I see exactly what they have done. As you can see here from our IC switch, we come up through this coil, and this is showing a feed through. So this should be a small piece of coax cable that runs up to the bottom under the tubes to feed the cathodes, and it's supposed to be grounded at each end. And what they done, for some reason, they had cut it short and then went back and grounded the cable further back in the radio and then run this jumper wire. I don't know if they accidentally cut it or burn it with a soldering iron or what they did, but yes, that is the wire that is supposed to be there. They just have the wrong type of wire. So if we try to get a good look here, sorry about the shakiness of the camera, that's that black wire right there, and you can see it splits off, and one side's grounded, another side goes through the feed through cap. Then it comes right on up here, and they've cut it there and put it on this big eyelet, and then run the rest of this big wire over to where the tubes are, which is actually ran the wrong way. It should be ran under here and then come up and connect right to the end of the our resistor here, shunt resistor. I got the shunt resistor back reinstalled. I wrapped a piece of wire around the end and soldered it, and soldered everything back where it goes. Now I need to deal with this crappy wiring they put in. Okay, so I got the old cable out. I got the new piece of shielded cable, and it goes down here to one of the pins, and the center conductor is connected to the pin, and then the ground is connected over to the ground lead. And then I've ran the cable right on through the chassis like it's supposed to be, and up and over here. So what we'll do, we'll get this put in where it's supposed to be. We'll connect the center conductor to this side of the resistor and the shield to the other side of our shunt resistor, and that should conclude that problem. Alright, so now the installation is complete. Our wiring is put back in as close to factory stock as possible. And again, this radio is telling me some stories, and I want to verify something before I go any further so that we will know the rest of the story. Okay, and confirmation is now confirmed. Looking here at the Heterodyne crystal oscillator board, we can see that this crystal starts out with 160, 80, 40, 20, 15, 10A, 10B. Then there should be 10C, 10D, and then 2 auxiliary slots to plug in extra crystals, and then just a blank slot. And you can see 2 crystals are missing, C and D. So looking at what has been done on this radio, I have to ask myself what bands has been installed previously in this transmitter and now has been removed. Like I said, it's supposed to be 29, 29.5, and they are missing. They left what looks like 10 meters. I haven't poured it to confirm, but I think I'll do that right now just to see. and that is a 3402 crystal, and I believe that is correct. And this is a 3452, and it does have FL100 on the back of it. So 28 to 28.5 is correct. But like I said, the other two crystals has been removed, and probably something else was substituted in it for a while. And like I say, I'm not kicking or knocking anything. I enjoy anybody experimenting and playing around, but there's a right way and a wrong way to do things. Plus, you know, this radio was made for amateur radio and no other band. But, you know, sometimes they do fall on other tech benches and then used in illegal services. I have our FL101 powered up and warmed up, and what I've done, I've connected two wires, just jumped over to the S meter going to our AF output meter with the S meter on the top, and we're going to look at the bias, and I will just put it in upper sideband mode and key to mic, and we can see we have bias, and it's not set too high according to that meter. I have used this on 101s before, where I cannot, you know, working on it, cannot see the meter on the front, so I always use this so I know about where it should be sitting at with this configuration. I'm going to now come over and put the mode switch in tune, and we'll put the meter in power output, and we'll have a look on our little meter, and I'll just switch it over to Mox, and you can see we have output. If we look over at our spectrum analyzer on our IFR, and we go to Mox, you can see we have output there. And looking over at the power meter, and we have output, and that is about it's like about 65 watts or so. So with that, we have brought this radio back in to somewhat life, you know, but we have to wonder, alright, we haven't checked to see if there's any modulation output or anything else on it. Frequency, let's just do a frequency check right quick. On tune, I'll turn the carrier way on down. We'll look over at the error meter. I got the IFR on 14.200. I'll set the error meter to 0, and I'll look at the display, and it's pretty much spot on. So that's 14.200. So that looks pretty good. Okay, I got the radio in the upper sideband carrier set. I need to turn the mic gain up just a little bit, and we'll just look and see if we have any modulation at all. Check 1 2, test 1 2, and we do. We look like we have plenty of modulation. And looking at again in AM mode, check 1 2, check 1 2, and we have AM carrier and modulation. Well, one of the good things about having two units, I was able to take the positive side of the meter loose on the other one, and just clip 2 jumper wires from one meter to the other meter, and able to go through and set everything the way it needs to be by using that meter, and pretty happy with the results. The other radio is putting out a full 100 watts, no problem. Seems to work okay, good modulation. So that pretty much means that the driver and the final tubes are in pretty decent shape. I was able to dip the meter, and it's it's equal on both sides. If you go to dip the plate and you see it dips deep one way, and then you turn it the other way and it's not as deep, then you can pretty much know that the neutralization is off. So I don't even have to worry about messing with neutralization. It looks to be pretty good. So yeah, no problems with that. Just going to have to find a meter and a couple of crystals, and I think we'll have this radio working like a champ. We'll go ahead and go through the capacitors and replace those, because they have some age on them. I've checked a few, they check okay, but with the age of the radio, I would feel much better to go ahead and replace them, especially the main filter caps, and all the caps on the regulator boards. Some of the other caps might be alright. I'll go ahead and change the caps in the audio circuit for transmit. So yeah, I got a couple of dial lights I'm gonna have to get, because the dial lights and meter lights are out. But yeah, finding that meter is going to be the toughest problem to do. So I really hate doing it, but we may have to end up pulling this meter apart and trying to rewind that little core. That is a job, because not only have you got the core on each end of the pivot for the meter, you got 2 springs that pull the meter back, and that's actually what the current flows through to get to the core. So yeah, it's going to be very aggravating. So anyway, there you have it. The FL101 is in working condition. Just got to find a few items, and then we're going to strip this radio down and most likely do a complete restoration on it. Clean it up real good. We're going to take the chassis and clean it, and the case we're going to put it in the sandblaster and get all this old paint off, and go ahead and repaint it back the original color. Now if you're looking just for something to get by with on paint, you can go to Lowe's and get Rust-Oleum 12 ounce winter gray. That's a gloss spray paint. It is item number 89137. Model number is 1982830. And there it is right there. And it's about as close to as the original Yaesu paint, that light gray, that you can probably find without going to an auto parts store and having it mixed up. So it, that works out pretty good. It's not bad at all. I have painted a few with that before, and it looks right decent. And don't forget, if you're interested in the Heathkit IM18, then let me know in your comments below. We'll be doing the drawing on this in a couple of weeks and giving this away. Like I say, you will have to rebuild the meter yourself, or at least change out the caps and calibrate it. I did check it out. It does work. but you know, it does, it's old, it needs calibrating, and you know, getting all those old caps out. So yeah, there you go. Anyway, again, leave your comments down below. If you like to support this channel, you can check me out on Patreon, and check out the website, links down below, and we'll see you in the next video. Bye.